One of the things we've been watching over the last couple of years, of course, have been various things changing in our climate. We're interested in increasing floods, increasing drought frequencies, changes in severe weather. These questions always come up. Are these natural processes that occur on normal timescales, or is it something else going on in our climate system? Is our climate changing? In particular, are we humans having something to do with it? Because what we're interested in, or what we're seeing, is that as the climate changes, as a number of things happen, we're very concerned about our environment for obvious reasons. Because the last thing we want is to be standing idly by when a storm comes up behind us or when things come up behind us. But more importantly, we want to be not caught unawares and paying attention to things that really aren't there. So the question I want to ask tonight is our climate changing, and are we, meaning humans, to blame for it? And what we want to argue is, or discuss is, what is the real climate change consensus? The first thing we can agree upon is that our climate is changing because it always has changed. The idea of climate being stable is essentially something we have never seen in the historical record. That is, whenever you look at climate change, we see fluctuations that always take place on a number of different time scales. And the one thing we don't see is the climate ever has been a plateau, constant temperature, constant precipitation for any extended period of time. The second thing we recognize is that climate is not simply average weather. The idea is that somehow climatologists become actuarial scientists, where we're really measuring means and standard deviations and maximum and minimal and ever changing. And it's the climate background on which weather probabilities occur. One of the things we talked about here is global air temperature reconstructions. Here we're looking at over the last 2,000 years. You can see a number of fluctuations associated with the arrival of the Vikings in Greenland, the end of the Vikings in Greenland, and the Little Ice Age period, which is the coldest period since the dawn of civilization. And now we've warmed up since then. The second thing we can agree upon as scientists is the current warming trend has resulted in a net rise of globally averaged air temperature of about 0.6 degrees Celsius, plus or minus 15 tenths of a degree. We can argue about the magnitude, but generally what we have seen has been a rise in temperature. And generally that rise has not been continuous. That is, it came in a very early spurt towards the first part of the century, sort of a plateau out in the middle of the century, and a second rise towards the latter part. The third part of our climate change consensus is that humans can and do have an effect on our environment, both local and global, including but not limited to increases in atmospheric trace gases and changes in the land surface. One of the things I've noticed in particular, this is Tallyville, Delaware, which is near where I live. This is 1937, and what you'll see is the land surface dramatically changes as we go forward in time. 1961, what you'll notice is more roads, more people, more buildings, more parking lots, less trees, less grasses, and so clearly that changes the landscape. And so what we've seen here in northern Delaware has been 70 years of anthropogenic change. This is anthropogenic change, has nothing to do directly with carbon dioxide, but nevertheless is anthropogenic change with the land surface, and that's what a lot of people tend to forget about human-induced change. Now, the scientific consensus is limited to these relatively trivial points. The real debate is, to what extent are humans responsible for the climate change we see? What are the future consequences of climate change, whether it be natural or anthropogenically caused? And what should our response strategies be? And we're going to argue that a well-informed, prudent response is always the only course of action. Now, the current warming trend has resulted in a net rise of globally average air temperature of about 0.6 degrees over the last century. So what's been happening since then? Well, the one thing we've noticed is that since the year 2000, in this case 2001, what we've seen in fact has been a decrease in air temperature. Now, I'm not going to argue that decrease is statistically significant, but certainly the warming that we saw towards the latter half of the 20th century has not continued into the early part of the 21st century. We also notice that the University of East Anglia has agreed with that in fact there is a plateau out at the end. And we've also noticed that the UK Met Office data also shows a decrease as well. One of the other things that we're interested in is the mystery of oceanic heat. One of the things we've measured in terms of the oceans are diving bells. And in particular, what these do is go down for a period of about 9 days. They stay at a depth of about 2 kilometers, where they then come back to the surface. They report back temperature, salinity, density, and position, so we can get information on that. And after about 12 hours, they sink back down again to 2 kilometers, where they continue to do this over and over again. What we've seen in this case has been the fact that these instruments suggest that the oceans, too, have not warmed up over the last 4 or 5 years, implying that at least something is happening to change what we currently saw in the latter portion of the record. We also saw that Antarctic ice coverage in 2007 was the largest observed conditions, and in fact in January 2008, the Northern Hemisphere snow cover was the largest January snow cover on record. So what about the disastrous consequences of global warming? I mean, it's one of the things we talk a lot about are air temperature. And in reality, nothing responds to mean global air temperature. Everything responds to local fluctuations. In this case, what are the weather events that result in the most deaths and have the greatest economic impacts? And how are they likely to change under global warming? And more importantly, what I'm going to address is how have they been changing? So we're going to come up with the idea of, in this case, Al Gore in his congressional testimony said the rising temperature has been accompanied by many changes, and those changes include droughts, which are becoming longer and more intense, floods and heavy rainfall, which shall increase, hurricanes, which are becoming stronger, and finally sea levels, which are rising. And so we're going to look at all 4 of those. So first, what about droughts? How have they been changing? In this case, we define drought as, in this case, hydrologic drought as stream flow or reservoir levels that fall below a certain threshold. It depends obviously on a lack of precipitation, but it can also depend on urbanization effects and increase in water-intensive activities. In other words, it's a supply and demand problem, and in some cases, drought can be generated by increased demand. As state climatologist, I'm often asked, are we seeing more droughts in the northern Delaware? My answer is yes. Is it anthropogenically caused? And the answer is yes. Does it have anything to do with climate change? The answer is no. We're not really seeing a change in the precipitation climate. What we're instead seeing is a change in the land use. We have more people on the land surface demanding more of a limited resource. So when we have a dry period or a dry season, the water doesn't go as far as it used to, and so droughts have become more frequent. So one of the things we want to look at is the Palmer Drought Severity Index, which is a measure of sort of a continuing drought that defines, in particular, growth patterns. In this case, this is a percentage of the United States in moderate or extreme drought. And what you can see in this case is lots of variability. You can see the 1930s Dust Bowl period. You can see the droughts of the 1950s. You can see other drought periods that occurred, but what you don't see is a long-term trend. What about the other extreme? What about floods and heavy rainfall? Well, there's a number of ways of defining flood, but in this case we define flood as stream flow above a certain threshold. It depends on the amount of precipitation. It depends on timing and form of precipitation. Usually I say many of the floods in northern North Dakota or in northern Pennsylvania, for example, are rain on snow melt processes, which now we're seeing played out quite a bit. We also have urbanization and channelization. The idea is that by building channelized rivers, that the water becomes much more efficient at moving, and in some cases much more efficient at creating a flood peak. In this case, I'm asked the same question. Are floods becoming more frequent in northern Delaware? My answer is yes. Is it anthropogenically caused? Well, yeah, it is. Look at the land surface. We have a lot more impervious surfaces. So when that rain falls, we don't have enough retention ponds to hold the water back. The water winds up in the Brandywine, Red and White Clay Creek basins fairly rapidly, and as a result, they're seeing more flood conditions. But it's not related to changes in precipitation. And when we look globally, or I should say in the United States, we see that the percentage of the United States in moderate or extreme wetness, this is the other end of the Palmer Drought Severity Index, again shows lots of variability, lots of wet years and lots of not so wet years, but certainly does not show any long-term trend. Now, one of the things we recognize as the world warms is that the poles should warm faster than the equator. There's 2 reasons for that. In this case, we notice that the pole to equator temperature gradient is what drives global circulation. The fact that we have cold poles and we have a warm equator creates a temperature imbalance. And as a result, we have an energy flow that takes us from the warm equator towards the cold pole. In this case, what we find is that as warming takes place, the poles will warm faster, and there's 3 reasons for that. 1, water vapor has a higher specific heat. So simply put, more water vapor in the air results in a more difficult or takes more energy to warm the atmosphere at the same temperature. Secondly, cold air is easier to warm than warm air with the same energy put. And third, we also melt ice and snow, which changes what we call the local albedo, or the reflected characteristic of the surface, which results in a warmer. So regardless of how the Earth warms, generally speaking, what we see is that pole to equator temperature gradient decreases. And in fact, in a warmer world, we expect the temperature difference between high and low latitudes would diminish. And it's precisely this difference that gives rise to extratropical large-scale weather disturbances. So with that in mind, we ask the question, does warming cause stronger and more intense hurricanes?